always me giving you the answer. Oof! Anyway. Oof. Oof. I don't even know. It's like an O and an oof all together. Oh no. I was curious what you guys could come up with, so I am wondering. Let me zoom in just a little bit because they're going to be a little bit crunched. We'll be a little crammed for space if we try to do it that way. What was the very first thing I asked you guys to do?
U and U.
Why?
Always good to find U.
Yeah, it's always good to find U, especially if there is a U. But how do we know there is a U? Because I had someone come back to my desk this morning from period 6 that was trying to go straight from a problem to like, oh, it's an LN one. I got the answer and didn't even consider the U. So they had it wrong, even though their big idea was right. But it wouldn't have made the match. Even if you can tell that it's going to be an LN one, you've got to make it match. And to make it match, you cannot legally proceed forward until we have rewritten it to look like a basic rule. Yeah? Are either of these basic rules that you guys have memorized in that whole chart of antiderivatives either from before or from yesterday?
No.
No, they are not perfectly like any of those rules. So we have to change. Now, can we do some quick distribution? Can we do some quick rewriting of the square roots to be fractional powers? Can we do some quick, like, divide everybody by the denominator and everything will be better? No. So, we go looking for you. All right. What do you guys think? Who's you for the first one?
2x.
Yes, if only.
1 plus.
Is 2x the innermost? Yes.
Yeah.
But it takes some strategy, it takes some wisdom to choose U. If this was U, how much better off am I if I have 1 over 1 plus square root of U? Not that good. It's still not a basic rule. So instead, we're going to say we want it to be 2x because that's a nice little sub, but it's not going to help us in the bigger picture. So we have to make it 1 plus square root of 2x. We have to make it that entire denominator. A little rough, right? Because if we have to make it that entire denominator, what do we always do as soon as we choose U? Because we cannot legally anti-derive until we have everything in terms of U. Or at least matching up in terms of U. So du says, okay, what's the derivative of 1? Everybody. 0. What's the derivative of? Ooh. Maybe you would want to rewrite this to take the derivative. What's the derivative of something to the 1/2 power?
Ooh, I've been thinking of
bring down the
integration.
And then make it negative 1/2. Who stays the same? 2x. And then we peel off our matryoshka and say, you're fine. Right?
That's intense.
Do you see why I'm trying to get more space on my page? We have to take the derivative of u to the 1/2. I know we haven't done tons of chain rule derivatives. Well, there is no chain rule for integration, but it's called because remember, it's u to the 1/2. And u to the 1/2, we bring down the 1/2, make it a negative 1/2, and then say times u's prime. So 2x is like the little inner matryoshka who needed his own derivative. Or this is the f prime of keep the g of x the same times g prime of x. Now, some of you are remembering that we're supposed to get dx by itself, right? That's my way, not CalChat's way. CalChat says, hey, make this up there. And you're like, it's not there. How do I make it? It's not. Go my way. Except even my way, I'll come to you, Cal. Give me one sec. Even my way would say, do you really know what you have here? Let's rewrite it to make it easier on our brain. So if I were you, I'd reduce the 2 and the 1/2, and I would rewrite this as 1 over square root of 2x before solving for dx. Sometimes, especially with these negative and 1/2 and whatnot. Now, Kyle, I'm going to solve for dx, but go ahead. What's your question?
Well, we already answered it.
Got it.
Are we going to kill anything if we get rid of the 2's?
Not at all. Because multiplication is, because it's always good to have a defense. That way you could have answered this like in the future on your own. You don't want to like be second guessing yourself. Multiplication is commutative, so I could rearrange those and 1/2 times 2. Okay, name of the game is plug it in, plug it in. So we don't have to stress about everything being perfect. That's CalChat, whatever. we just go for it, and then we reconsider what we have. So coming back up here to the top, I got my u from this denominator, right, guys?
Yes.
So I'm going to put my u right there. I have a dx, which was the whole purpose of solving for dx. I'm going to go ahead and plug that in. And what do I get? 1 over
U.
times, and then just plug it in, plug it in. It doesn't have to be perfect, remember? We just plug in whatever we have. Make it legal.
Is it legal method?
Well, this is legally substituted. The problem is it legal for us to move forward? No. So if we can't move forward, what do? Look back. Why am I getting a blue pen? What do I have? Where else does that appear? Wait a minute, integration on crack, you were only looking for x. Well, I don't know, I need a square root of 2x, so I found one. I looked back and I found it, and I said, ooh, hey, who are you? What's another way of writing the square root of 2x? You see it? So the same way that we did on Friday, the same way that we did Monday, where you guys were like having an extra piece and you had to go back and I double underlined the x and then we went and found it. Yeah, he's right there. So go get him. Okay, so drop the one. And now what can I do?
Can you divide by radical 6?
Why do that? Why not just plug in? Remember? Integration by crack. Integration on steroids. Technically not the integration that is, it's the substitution that's weird and crazy. It's like we don't have enough, so go back and do some more substitution. You can do more substitution? Yeah. You can move this statement around to be whatever you, well, not to be whatever you want it to be, but to solve for something if it would be helpful, and then plug it in. So I end up with, oh my goodness, something that is helpful. U minus 1 over u. Now this is not a basic rule. But remember how I said a second ago, okay, if it's not a basic rule, is it something that can be distributed and then solved, or radicals written as fractional powers and then solved, or denominators that are split up and then solved?
Yes.
Can I make this, you guys like making this u to the negative 1, huh?
Yeah.
So weird, but I love y'all. Alright, so we can go ahead and make this a u to the negative 1. We can go ahead and distribute. I like just saying, hey, distribute the division or the multiplication of 1 over u. I like that better in my head, but yeah.
If you just split it, would be u over u minus 1 over u?
Which is why my brain likes it, because u over u is just 1. 1 over u is just 1 over u. But either way, the same thing's going to happen. U to the 1, u to the negative 1, that's u to the 0, which is 1. Minus 1 u to the negative 1, which is 1 over u. So either way you do it, you end up with the exact same statement that is now basic rules. Basic rules? How do you integrate any constant? Finally, I can get my red pen. Yep, it's going to be 1 times the variable, and the variable is u. Why? Because what's the derivative of any variable? 1. What's the integral of 1 over u from yesterday? Or from our basic rules? Absolute value of u plus c. And then what's the last step? If it's an indefinite integral and I don't have to worry about bounds, plug in the u, right? And the u up here, I don't remember. 1 plus square root 2x. So I'm going to have 1 plus square root 2x minus ln of 1 plus square root 2x plus c. And technically, what are the only types of values that come out of the square root?
Positive.
And what's 1 plus any positive number?
Square root.
Positive, which means there is absolutely no need for that absolute value. And to be honest, this little 1, couldn't he combine with this c? So couldn't this also be? You could kind of have like a plus c1 and then this is like a plus c2, but they wouldn't show that. That's just a constant, so a constant can go join another constant and then not really be important or not really need to be shown. Where the absolute values go, well, he's always positive, so forget it. That's redundant. It's redundant. It's not like as bad as in English if you say, I'm not going nowhere, and it's like, oh, you're going somewhere. Grammar Nazi, that's me. But I would be the one to do that. It's not like that where it like undoes each other, but it is saying like, I don't know, what's an annoying redundant statement that people use?
Like a bunch of oxymorons?
No, not oxymoron, it's just redundant. You're saying the exact same thing. Like people are doing it, although technically when they say that, you can say it's double negative, which means positive. But it's similar to that in the sense that like you're trying to say it twice and it's really not working or it's really not useful or helpful. So it's redundant. It's redundant. Which means that you guys would need to be able to make the match because there's no way that they're going to keep a redundant absolute value in there. They're going to get rid of it. So the question is, do you realize that this is the exact same thing in a legal way? But guys, what all was going, oops, okay, well I'm saving it. Yay, hello, good morning. But when I zoom out, what was hard? Can we just stop and detox for a second? Can we debrief from that problem because it was a bit messy? What's the very first thing we did?
You.
Okay, very first thing was you. Now, what did you think you was? Yeah, and understandably so, because you're like, it's the innermost, true. But with these new integration rules, what sometimes is going to be the innermost? The entire denominator. Now, I'm going to go ahead, and I think they use, even though I'm not requiring you guys, you can do the x dx if you really want. This one's not going to work quite as well. I'm going to put in those u's just because we're going way harder than just x's now. We're going way harder than just x's. So 1 over u can become ln of u. Oh my goodness. Well, if that's true, sometimes we'll be taking that entire denominator, which is what you just saw. And the reason why was exactly what Mariah said. When you guys chose the u to be 2x, I'm like, but guys, would that have helped? If we had 1 over 1 plus root u, like, we don't know that. How are we going to solve that any better than we could solve the beginning one? So you have to think ahead as you're getting more and more used to this. And as you're choosing a u, pause. Before you do lots of work, be like, wait a minute, does that actually help me? If the u is 2x, no. If the u is the whole thing, ooh, it's an ln. But wait, was it just an ln? No, you can't just be like, I think it's an ln. Answer, done. We have to walk through the steps of once you find u, then what? What's the next step? Just the next step. Find the derivative. Good. du is equal to u prime dx. And then, okay, if it looks messy, make it look prettier, but eventually get dx alone. And then we say, we don't need things to be perfect, whatever. Let's just go look and see what we have. Let's put in that dx expression. Let's put in our u, and let's reevaluate. When we reevaluated, was everything good and ready to move forwards? No. So instead of moving forwards, we looked back. And we said, oh, hey, we see you up there. Let's go figure out who you are in terms of u's. Get that plugged in, and then all of a sudden, ooh, I think I can play, I can solve, I can plug in, I can be done. Dun, 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 dun. What's different with this guy over here? On this side. Hopefully. But I asked you guys to start with u and du, yeah? So what do you think u was?
No idea.
If you didn't know, actually it is. It's perfect. X minus 3. In some ways it's perfect, and in some ways that should make you like a big old huge question mark being like, what? U is x minus 3. But
du is 1.
That means du is 1 dx. Which means, what's going to be bad if I go plugging in right now?
Can't feel do anything.
Look at that numerator. Like, I'm going to have 2 different places where I have to do integration on crack, and when I do integration on crack, because that numerator is not going away, that can be a u, that can be a du, and I have all this blah, 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 blah. You got to be kidding me. So I have to come to this, and I have to go ahead and solve for x and get x to be u plus 3, and I have to plug it in there, and cube it, and there, and square it?
No.
You could.
No.
Or you could learn from those that have gone before you that there's always a better thing to do when you're given an improper fraction. This is taking you back to partial fractions and pre-calculus. Because anytime you were given an improper fraction with partial fractions, we never went straight forward. We said pause, time out, slow down, divide. did partial fractions, we would never go straight to partial fractions with improper fractions. We would divide first. Same thing with integrals. So here's the crazy thing.
Oh, that's why.
Andrea, you were totally right that u is x minus 3. The struggle is we shouldn't be doing it yet. So even though it's right, I totally understand why you and everyone else is like, it's not going to work because it's not yet. We're going to use the green pen. If I were you guys, come on. I do this a lot. Have you actually started taking me up on my advice? Do you have a special colored pen or highlighter to say AP-ish or tricky or like, oh my goodness, tune in to what she did in this problem? Your brain would not think of dividing unless you study that, unless you memorize that, unless you practice that. But it's an improper fraction. It's an improper fraction. And whenever we have improper fractions, ooh, division could make the world of difference. Or a world of difference, maybe not the world. That's a little. A 0x, oh yeah, that's what you do. Can't we do synthetic? If you love it, do it. But you can't always do synthetic. What if that was an x squared? If that was an x squared, synthetic is illegal. Remember, synthetic can only be done with an x plus or minus constant.
Then our derivative would be different.
Also true. But still not as nice as that, right? Are you guys doing polynomial long division by realizing x goes into x cubed x squared times?
This is going to be 0.
Oh, they all cancel out? Wait, but I still have 0x plus 5. Wait, 0x is just 0. Don't I have a remainder?
Of 5 over x minus 3.
Check it and be amazed.
I'm amazed.
What did I just do? I just took this mess and figured out it could also be written as. Which one would you rather anti-derive? That one or that one?
That one.
Yeah, I do. We'll work on your division, it's okay. But check it, if I were to throw this in there, can I anti-derive x squared?
Yeah.
Andrea, why was x minus 3 my u? Because eventually it's the denominator of something that I can handle. I just couldn't handle it way back then.
Why would you be u now?
Well, technically, to be honest, can't I sort of, that's going to be a little messy. Hold on, let me see what I can do. I want to squish it all. Why am I squishing it all? Why am I moving a lot of this over here? Because technically, this u stuff only needs to be used for him. Can't you anti-derive the first guy just as he is? Oh my goodness, what's the antiderivative of x squared?
1/3 x cubed.
Oh, that was easy.
I've been right.
Now I have 5 over who? 5, well, 5 times 1 over who? 1 over u. And then du is just dx, so dx is just du. Oh my goodness. How did that mess at the beginning turn into that?
Division?
Division. Go pre-count.
Modern equations for modern
Division. Go pre-count. Some of you might have totally not been listening or not caring or not hoping I was wrong when I said, hey, polynomial division is actually super, super, super useful. Well, here you go. Polynomial division is actually really, 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 really useful sometimes in taking an impossible problem. Okay, not impossible. Andrea, you mentioned the first. You could have taken that little integration on crack and you could have taken the u plus 3 and you could have cubed that using Pascal's triangle or just using polynomial multiplication. You could have squared it. You could have then simplified it all. Then you could have divided every single piece by u and you would have gotten to the same place. Just would have been
Yeah. 2 hours.
Or just divide, right? Yeah. Because division says, wait a minute, wait a minute, wait a minute. There's a whole polynomial. There should be a squared in there somewhere. Oh, squareds are easy to anti-derive. What's left? I don't know. I'll deal with him when he comes. Okay. But my kiddo that came back to my desk this morning from period 6 who was showing me a problem where they had seen something and they were like, yay, it's ln of. They had done a problem like this where the ln is just there with no extra constant because the du was just 1. But as soon as I put a 2x, or as soon as I put a 3x squared, or as soon as I put a 7x, du will not be 1, which means this will not just be a strict substitution of dx equals du, which means this won't just be with an ln, it will also have a constant. So please don't stop doing u and du and legally proceeding forward. Hey, so there's another part of homework. Some of you guys have seen if you started late when I posted it, or if you got it from a period 6 kiddos, in that there's going to be e's, and not just e's, there are also going to be
hi.
b's.
Good morning.
Oh dear.
My name is
Do you remember that was a thing once? Now, hold on. Before we get to this, there's a marker missing. Before we get to the b, hold on. He's the harder guy. Let's review e real fast because a couple of you are struggling a little bit on that. What's the derivative of e to the u? Yeah, e to the u times?
U prime.
So, what does that mean? Every derivative rule can be written as an integration rule. This means that an integral of e to the u du, who had the u prime in it, goes backwards to be e to the u plus e. Boop. Now, do we already have an integration formula that has an e to the u in it? No, but we do have one that has an e to the x in it. And what's the integral of e to the x dx? E to the x plus c. But where are some of you going to get confused as soon as you have u's? You're going to be like, oh, e to the u times u prime. No, that was the derivative. You're going backwards. Right? Backwards.
Yes.
So then what does that mean for boo? D do boo, right? Derivative, d do boo. Derivative of b to the u with respect to u is boo, lim, boo, lim, boo. Derivative of b to the u is b to the u, l of b times u prime. Wait, but that's a derivative. Okay, hold on. Every derivative, I don't have room over there, let's come down. Every derivative rule can be an integration rule backwards. So what does that mean if I have a b to the u du? U prime is there, has been dealt with. B to the u is there. Who's not? What would CalcChat do? CalcChat would say, I need this perfectly in there before I can proceed forward. Perfectly? Well, I don't know how to do it unless I do an ln of b over an ln of b. And what do I need in there? This one. So then it would say, like, oh, okay, let's make it perfect. And let's put that little ln of b just kind of, I don't even know where to fit him. There he is. And now I have a b to the u, ln of b, and my u prime has been dealt with. Now I can go backwards, but as I go backwards, what do I have chilling out in front?
1 over ln.
Ooh. The 1 over ln of b, guys, is super similar to x to the n plus 1 over n plus 1. Why is it over n plus 1? Because the derivative rule has a constant coming and I need it to cancel out. That's what's coming here. A b to the u has an ln of b coming and I need the ln of b to cancel out. But to be honest, we could also just, I don't know, maybe memorize the rules. Yeah. I have a question. No.
Well, I was just thinking, like, because we were talking like this is what CalcChat would do, so I was trying to figure out what we're going in the beginning. So
because CalcChat would need it to match perfectly before it would make the answer. So match perfectly, it would need it to look like this. But the du is there, the b to the u is there. ln of b, it could be 2 to the, so ln of 2, or 5 to the, so ln of 5. It's a constant. Constants are allowed to come out in front, so they multiply by 1 creatively, bringing in the ln of b to match the rule perfectly to be able to go back. Yep.
You combine it with 30.
Well, that's the, yeah. Was it you guys that wanted like a blank card to do whatever you wanted with at the end?
No.
No, that must have been period 6. Oh yeah. They wanted to make number 50 their own card. Okay.
What does that mean?
I don't know. They want to make a card out of something. I mean, this is a short one. We definitely could put it with the log card. I don't know if we need to make it its whole new card. However, guess what? One of the most easily forgotten integral rules is of the entire year. Let's make it its own card. Yeah, because we put together the motion card. I think we're doing okay. And I want to make it its own card because I want you guys to make a huge deal. First of all, you do not need a U prime because we're not deriving, we're integrating. Oh my goodness, you do not need a U prime. We're not deriving, we're integrating. We're going from e to the u, having dealt with the u prime, and going backwards. However, when we go backwards with this one, the L and the B is missing, so we need to divide by the L and the B so that way the constants work out. I think we're on forever number 40?
Yeah.
Go team.
Wow.
Good 10 miles.
I know.
Right? Do you feel it? Do you feel it?
You guys?
We have chapter 5 and chapter 6. Chapter 5 and 6, neither of them get split up into an A and B section, and they both have like 3 or 4 sections, and then they're done. So, we're getting there. Big concepts still to come. AP. You guys have been really exposed to AP multiple choice that are like make it match ones. You haven't been super exposed to the concept-y, really tricky ones, besides like practice tests, bonus practice tests. But FRQs. So with those, these are just E's. These are just E's. I love E's.
I love A's.
I love E's because, oh, it's easy. We just need to say this and be done, right?
Yep, that's exactly what happens.
Yeah. Problem is, it's a definite integral, so you need to plug in bounds, so no plus C. And the second problem is, that only works if it's an e to the what? X, which it's not. Okay, fine. Or an e to the
U.
So where's your u sub?
3 minus X.
Mm-hmm. Don't go getting cocky and acting like a Calc BC kid, because you're probably not going to be thinking the u sub in your head if you're trying to make this go this fast. If you're not thinking the u sub in your head, you're going to get it wrong. Oof.
Steve's 1.
Oh! Negative 1.
Oh, sorry.
Why is that important? Difference between getting it right and getting it wrong. Yeah? Because when we go to plug in, we're going to have e to the u with the du, and I need the negative. Now, what are we doing? Are we doing u bounds? Are we going to make this a definite integral and never have to look back to the x's? Or are we kind of just going to stay with what's there, get back to the x's ourselves, and then use 3 and 4? What are we doing?
Use.
Oh.
We have both. All right, I'll show both.
What?
The u, getting back to the x's would say, okay, hold on, wait a minute. It's not indefinite, it's definite, but I can't put the 3 and 4 because they're x's, not u's. And so then we're going to go ahead and say, oh, it's e to the u. Plus c, but we're going to throw a negative, which is going to lead us to negative e to the 3 minus x. Can't do equals because an indefinite wouldn't equal a definite, but I do have my bounds out in front. So I can kind of just use my arrow to say, oh, that's right, I have x's. And then you would plug and chug, right?
Yeah.
My u people, you would say, I don't want to have to go back to x's. Let's just take time now and figure out what is u of 4, what's going to be on the top of this in terms of u integral, and then what is u of 3, what's going to be on the bottom. So I have 3 minus 4, and I have 3 minus 3. I'm going to get a negative 1 and a 0. And you're going to say, the antiderivative of e to the u is e to the u, and I'm just going to plug in 0 and 1.
That's easier.
Yeah, because it lets you do them plugging in separately. Kind of makes it a little bit nicer, prettier. Same math. Same math. Yeah, because this one's going to say, oh, it's negative e to the, wait, negative 1. I know, we should sue.
Yeah.
Minus a negative, which is plus e to the 0. Just kidding, don't sue.
Negative e to the negative
1. Careful, John. I wrote a positive 1. I wrote it wrong. It was a negative 1 because of plugging in. I wrote it wrong. So I did put the negative back in. So then it's f of b. Remember to plug at the top, guys. So negative e to the negative 1 minus f of a. We could have like switched it to make it prettier on ourselves, to make it go from the lower to the higher. We just had to put it in this order because of matching it up with the 4 and the 3 in the proper location. But if you had switched the bounds, you would have changed the sign, and it would have turned out to be the same thing. But check it. What happens if you do this the old-fashioned way? Well, negative e 3 minus 4 minus negative e to the 3 minus 3. It's the same thing. You're just doing that work down here in the antiderivative as opposed to doing it separately. So this one we end up with negative 1 over e plus 1. This one negative 1 over e to the negative 1 plus anything to the 0 power is 1. But would you guys be able to make it match e minus 1 over e?
Yes.
What'd they do? What'd they do?
Find common denominator.
Common denominator. They multiplied the 1's by e over e's, and they wrote the positive guy first and the negative guy second. So e over e minus 1 over e is e minus 1 over e. E over e minus 1 over e is e minus 1 over e. Could the e's get nasty?
Yeah.
Yeah, I suppose. But before we do a nasty e, can we go find a b one? I think I have a b one on the next page. I think before we get to nasty e's, I'd rather us just do a b. And by b, I mean a boo. And by boo, I mean a b to the u. Let's go find one. Ha! There's one.
Whoa, I don't like the bottom one.
Here's the honest truth.
Yeah, I like the bottom either.
As opposed to the non-honest truth. This one's easiest out of the 3 that are up here. This is the second easiest, and that's the third easiest. But because of how much we don't like boo, some of you would tap out on that one, tackle that one, and then kind of get stuck in a rabbit hole.
No, okay.
Me either. Neither did Alex. Okay, so we have a b to the u, yeah? Now, if some of you are amazing, and I'm not saying you're perfect. We all know that, because I'm not. But, coming back, if you're amazing, you're like, ooh, I think it's something like this. Something like that. Now, hopefully you won't make that jump. That's a really dangerous jump. But the same way that e to the u leads to an e to the u, b to the u leads to a b to the u. But it's not an e, it's a b, and it's a u. All reasons why we shouldn't go jumping there. But if your brain's thinking that, at least you're on the right track. Because then you also can be like, ooh, it's a b to the u. Ooh, so who's you? Yeah, at least it tells your brain what u is. Wait, so if u is negative x, what's du? Pause. You have a rule for this. You go. Get your dx alone. You don't need me for this, and I need to get Algebra 1 stuff ready to go, because if they walk in and it's not ready to go, we're all in trouble. But, you guys have a rule. Ready, set, like 30 seconds, maybe 60. You look at your b to the u rule. It's a new forever card, and it's a forever card on purpose. I didn't have a break. So, did you guys go ahead and get dx by itself? Did you get up here and did you say like, hey, the u came from there and the du needs to go in the dx spot, but ooh, there's a negative.
Negative.
Ah, but now is it just perfect for the rule?
Yes.
Because do you realize b just means constant?
Yes.
Which I have. I have a constant, so it's a b to the u. And what do you do with b to the u's? Well, you do the whole negative 1 over ln of who?
5.
B. Exactly. So yeah, 5. Times b to the u. Who's that? Oh, it's 5 to the u.
Oh, yeah.
Press C. Dun, 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 dun.
Miss D, I'm supposed to go to you.
Because what did we start with? Terms of.
X.
So, am I incorrect in stating that? No. But am I fully correct in finishing by doing that?
No.
So what are you supposed to plug in?
Yes.
Good.
And if it's make it match, would they multiply the C?
So I did it illegally.
See what they combine. The fraction and the 5 negative.
That's a good question because I have the u, which is great, but when I go and put in the negative, Kyle, why are you saying the fraction? I don't see another fraction.
It's 5 over 1. 5 is the negative x over 1.
Yes, and whenever there's a negative exponent, what does that technically mean? So couldn't it technically be 5 to the x ln of 5 all in the denominator and then plus c?
What?
It's a negative exponent. They can pop it down.
What the negative that make this?
No, and here's the reason why. Good thought. Why it's looking at our rule, realizing it's b to the u over ln of b or 1 over ln of b to the u plus c. The negative is in front. Are you wrong in saying that the negative does distribute? No, you're totally right. But remember that this is an arbitrary constant. So if I had a C1 here, let me pretend that wasn't there. If I had a C1 here, when I go to distribute, this could technically be a new constant. So if I had like a +3, the negative would make it a -3. I'm like, well, it could have just been a -3. Does that make sense? So I'm kind of allowed to play with just a little bit. We don't put like, if there's a 2 in front, 2C, or a -C. We just say, oh, it's going to make a new arbitrary constant that will solve if we ever use. Does that make sense? So you're not wrong in saying that, it's just the AP won't show you that. Wait a minute, why did I say the second one is even easier than the one over here? If you understand that one, what should your U be in that one?
Sin X.
Yeah, and if your U is sin X, who's your DU?
Cosine.
Yeah, positive cosine. It's a struggle, we should make a chant or a song or something. dx is equal to du. So when I go to plug in, isn't this just a 2 to the u? Du?
Or did you just...
No, because I didn't ignore it. U sub allows me to not go straight to a dangerous answer, but to process and make sure I'm going negative. And why does this one not kill a bunny? Because there was the cosine there. So it's as though, what if there had been a 6 right here? That would be right. But since there's no 6 and no u sub happens. But this one, u sub happened. I saw the cosine. I put in the cosine and said, oh, hey, were you prime? And now it's a b to the u, and a b to the u has a perfect b to the u integration formula, where I can do 1 over ln of b times b to the u.
Hey, can you put the 2 sin X on top of that one?
Yeah, you can put it on top if you want, like make it over 1 and just whoosh. Sure. Yeah, sorry. It was black, and then I wanted to do it in red, and then I just didn't decide what I wanted. She's going to the game. Okay, so how about that one? What would your U be?
E to the x plus e to the negative x.
Because couldn't the u be to the -2 power something I could do?
Yes.
When you take the derivative of e to the x, isn't it e to the x? And the derivative of e to the -x is negative e to the... I don't like the 2! Fine. Figure it out. Bye, guys.
No one likes the 2.
Tomorrow we're going over questions in grading 4-6 and then any remaining residual questions on 4-5. So have your homework ready for like a work-ish half day. Sound good? Come support the game if you can.